Mellin transform of ln of 1 plus x. So in this video, we will basically find the Mellin transform of ln 1 plus x, and that comes out to be pi cosec pi s by s. Now let's see how do we. So for our case, we can define Mellin transform of a function and transform to the world of s. This can be defined as integral from 0 to infinity e to the power no, not e, that's for Laplace transform, x to the power s minus 1, and then f of x dx. Yeah, now for our case, Mellin transform of ln x plus 1 transform to the world of s, that is integral from 0 to infinity x to the power s minus 1 ln of 1 plus x dx. Yeah, now how do we proceed? So basically, if you just stop for some time and like try to observe the problem, uh, you can notice that if we are able to differentiate the second expression, and if we get something like s minus 1 by 1 plus x dx, we will be able to use beta gamma function and solve it easily. Yeah, so what you can do is you can try to use the Feynman's technique and then differentiate. There might also be other ways which you can look into, but this is also one of the ways that can work. So let us make it 1 plus dx. Okay. And so if you now differentiate with respect to t, when it goes inside the integral, that becomes a partial derivative with respect to t. Yeah, and so this x stops will just become a constant. Yeah, when partially differentiated, this axis will become constant and one t will be variable. So di by dt is integral from 0 to infinity of x to the power s minus 1 by 1 plus dx. Yeah, and then t dt. Okay, now and then if we differentiate with respect to t, also there's not t, I'm sorry, because we are differentiating with respect to t, only x will be there, x and then dx. Okay, now fine, we have got this. Now this is under trouble that there's, okay, so first of all let me write in a proper way, and then I will tell you what to do next. Probably you have guessed what to do next. Now since we don't want a tx over here, what you can do is you can say that y equals to tx and simplify the problem. So you get di by dt is equals to integral from 0 to infinity, we have x equals to y by t, so t to the power minus s, yeah, and y to the power s by 1 plus y dx equals to dy by t. Yeah, is that fine? Wait a second, we are defining y equals tx. Yeah, so that's why x equals to y by t. Okay, I think that's fine. That's fine. Let's proceed. But why does this seem to be a problem to me? No, okay, that's not a problem. Now di by dt, this is equals to t to the power now minus s minus 1, and then now this is just gamma of s plus 1. Oh, wait a second. Okay, gamma of s plus 1, and then gamma of s minus 1. Yeah, this is the standard beta function, and you can do it on your own, or not s minus 1, 1 minus s, I'm sorry, 1 minus s. Yeah, and okay, now yeah, this is thing. After this you have di by dt is equals to t to the power minus s minus 1. Now this is pi by sine pi s. So pi 1 minus s. Yeah, so what do you get? Di by dt is equals to t to the power minus s minus 1 by, now this is minus pi by sine pi x. Yeah, sine pi s, because of minus sign we can take that out. Now if we try to integrate both sides, the minus pi by sine pi s is just a constant, and t to the power minus s minus 1 is a variable, and if we integrate, we get I is equals to minus pi by sine pi s t to the power minus s by minus s, yeah, and plus c. Now notice that when t is equals to 0, this is just ln of 1, so the entire integral is just 0. That's why at t equals to 0, entire integral is 0. Yeah, and this cancels out. At t equals to 0, entire integral is 0, and this expression is also 0 plus c, so that gives us c equals to 0. We get I is equals to, now this is pi by sine pi s t to the power minus s by s. Yeah, now our answer is actually at t equals to 1. Yeah, t equals to 1, now we have the answer. So let us find I of 1, and we have pi cosec pi s by s, and that is the answer. Yeah, because the t is 1, and this one will just be 1, and so you get the answer. So that is it. Hope you enjoyed the video. The flow was, let's talk about the flow of the problem. I used Feynman's method. So we let t over here, we differentiated, we made a u substitution, we used beta gamma function, and then we integrated, we found the c, and we got the answer. That was it. Hope you enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming videos too.